Hello dear students, welcome back to NEET WORLD. So this is our fourth session on this equilibrium discussion right now. So equilibrium we have started, we have discussed chemical equilibrium and also we are discussing about ionic equilibrium, right? So in the ionic equilibrium also we have discussed electrolytes, how can we classify electrolytes, weak and strong electrolytes, and therefore the degree of dissociation right now. So writing Kc, Kp values for chemical equilibrium we have discussed and the relation we discussed and Gibbs free energy relations discussed right now, and PYQs related to this chemical equilibrium and ionic equilibrium are also solved in the previous sessions. I hope you have watched those sessions, right? So in this particular session we will be discussing about the acid base theories first, and after that how can we find pH of acids and bases, as well as we have different acids now, weak acids, weak bases, or weak strong acids, strong bases we have now, right? So for strong acids how can we calculate pH, for weak acid how to calculate pH, similarly pOH for weak bases and strong bases. Okay, these things need to be discussed in this particular session. Okay, right. Let us start this session with a very basic understanding of this acid base theories first. See, we have three acid base theories which are very important for us to understand. First one is Arrhenius concept of acid base theory. So as per this Arrhenius acid base theory, so now in this theory acid is considered those substance which increases concentration of H plus ion in this water. So if I take any substance in the water, so what I am taking to the water, if we add to this water, if we add any substance, like I am saying HA is a substance, so when this HA is added to this water, if it is increasing the concentration of H plus ion in the water, okay, so simply I can write H3O plus and A minus. So now since this substance is releasing H plus ion, therefore concentration of H plus ion is released in the water, then we can say the substance as acid. Okay, acid. Similarly, if there is any substance that can able to increase the concentration of OH minus ions in water, then we can call them as bases. This is simple Arrhenius acid base theory. Okay, and after that we have Bronsted-Lowry acid base concept. So as per him, so what he says is proton donor is an acid. What is that? Proton donor is an acid, and proton acceptor, so this is with respect to this H plus ion only. So proton donor is an acid, proton acceptor is a base. Okay, and then now look at this, there is a concept called acid base like conjugate acid base theory. It's very simple. See, if there is a substance like HA, again I am taking, or HX you can take, so this HX, if it is releasing H plus ion, so I can say HX is a substance that is donating H plus ion right now, so therefore HX is called acid. Okay, HX is called acid now. Okay, so now I have a substance like X minus, so this is accepting a H plus ion and forming HX. So now what I can say, the X minus here which is accepting this H plus ion, so H plus proton acceptor, H plus ion acceptor is called bases. So I can say this X minus as a base. So from understanding this thing, see, when an acid is releasing H plus ion, the negative part formed here should be called as base. What base? Particularly it should be called as conjugate base. So the conjugate base of this acid HX will be X minus. Okay, so this is what conjugate acid base theory means. After releasing one H plus ion, the negative part formed is called its conjugate base. Okay, and see, if this is a base, once if it after accepting H plus ion we got some HX, now this should be called as acid. Okay, and particularly you should call it as conjugate acid. Okay, so there are two things, proton donor, after donating a proton, the remaining negative part is there, now that should be called as conjugate base. Okay, so this will be the scenario. And if we have a base that accept a proton, so after accepting H plus ion, after accepting that proton, the whatever the species formed should be called as conjugate acid. Now why it is very important? Yes, this conjugate acid base theory is very very important. You can able to understand, or you can able to give the order of basic strength or acidic strength of different compounds by looking at their abilities to donate proton or accept a proton. Okay, let me show you some questions also based on this conjugate acid base theory from EAPCET, or even in JEE NEET also these questions are repeated. Okay, so let me explain you the concept first, then we will solve the questions. Okay, for example, I am saying H2O is there, so H2O is accepting a proton, therefore it forms H3O plus ion. Since it is accepting a proton, water is accepting a proton, so you can say proton acceptor is a base. Whatever the species formed here should be called as conjugate acid. Base forms conjugate acid by accepting a proton. Now same water I am taking, but in this case I am representing the reaction in different manner. See, I am saying it as H plus ion is released and OH minus ion is formed. Okay, so now our water is donating a proton, so proton donor is called acid now, so this is called acid. After releasing H plus ion, the negative part formed should be called as conjugate base. Okay, hope this is clear. Now by understanding or by looking at these two reactions, you can give one generalized statement. An acid base pair will differ by one proton. See, if this is an acid, if this is a base, conjugate acid, how do they differ? They differ by one proton. See how many, what is the difference in their molecular formula? So they differ by one H plus ion. Similarly, if this is an acid, the conjugate base is formed here. So it is H2O, this is OH. It means one hydrogen is decreased. So simply you can say a base and its conjugate acid will be differ by one proton. Okay, so always acid will be having one proton greater than its base. Okay, so this is the simple thing you can remember to understand the concept of conjugate acid base theory. Okay, so now one statement I am writing here which is very very useful to solve the question. See, I am writing a conjugate base of a strong acid is weak. It means you can understand in this manner. See, I am writing HF or HCl, HBr, HI I am giving you. So these and HF I am giving you. So out of this acidic strength, if they ask what will be the acidic strength order, see HI is stronger acid because due to larger difference in this H and I minus, therefore H plus ion is released here easily because of larger difference in their sizes. The weaker bond will be there here, that's why H plus ion comes out easily. So this is stronger acid. So this will be the acidic strength order. Okay. So now if I ask acidic strength order is done. So if I ask basic strength order, so how can you answer? See, basic strength order, what is the basic strength order here? See, from this H plus, after releasing H plus ion we got F minus, from here Cl minus ion, from here Br minus ion, and from here I minus ion right now. So now I am asking what is the basic strength order of this F minus, Cl minus, Br minus and I minus. So what I told you, if a conjugate base, like conjugate base of a strong acid will be weaker. So if this particular substance given is stronger acid, then its conjugate base will be weaker. So it means which is weaker base here? Iodide ion, because it is its conjugate acid. See, HI is a stronger acid now, whatever the negative part formed from it is called conjugate base. So that conjugate base will become weaker. If acid is strong, its conjugate base will be weaker. So therefore order will be in reverse manner in this way. Okay, this will be the order of basic strength of the compounds. Hope whatever I have mentioned here it is clear. Now let me tell you one more question so that you can answer me. I have H2O and H2S. Okay, so out of these I am saying H2S is more acidic. So more acidic means what is the conjugate base formed here? SH minus and OH minus. Out of these to which is stronger base, you just comment me in the chat box, like just tell me your answer in the comment box. Okay, so what is your order? See, this is what acidic nature I am saying, this is acidic nature, then I am asking basic nature for their conjugate basis, basic nature for their conjugate basis. Tell me your answer in the chat box for this particular question. Okay, right. Let me move forward with few more things. Okay. Look at this question. Can you answer me? HClO4 is a treated with water so that it is becoming H3O plus and ClO4 minus. So now tell me which statement is correct here. HClO4 is a conjugate acid of water? No. H3O plus is a conjugate base of H2O? No. See, always acid will be having one proton greater than its base. Okay. So H2O is a conjugate acid of H3O plus? No. ClO4 is a conjugate base of HClO4. So option 4 will be perfect answer for the question. Right now, very simple question it is. Let me make it smaller. Right. Yes, next, will you answer me the next question here? Yeah, let me show you few questions so that you will get more clarity on this. See, look at this question, what they are saying, what is the order of relative basic strength of the given 4 conjugate bases? Like what is the conjugate bases given here? ClO2 minus, ClO3 minus and ClO4 minus, right now. So now these are the anionic parts. They are asking basic strength for this, basic strength they are asking. Now what I am taking, just consider their conjugate acids, acids of this O3 and HClO2. So if you consider this, just look at their oxidation state. Here +7 we have, and this is +5 and this is +3. So where do we have maximum oxidation state? So in this now, so whenever we have particular element with more number, like different number of oxygens, and the species having greater oxidation state will be having more acidic nature. Therefore this will be this HClO4 perchloric acid will be more acidic here. So if it is more acidic, this is the acidic nature I am saying, acidic nature I am saying. If this is more acidic, its conjugate base will be very weak right now. If it is more acidic, this will be weak basic. Therefore order will be in this manner. That's it. So what is the basic strength? ClO2 is greater than ClO3, then next is ClO4. So first option will be a perfect answer for the question. Okay, right. Next, let us discuss few more things. Here I am explaining Ostwald dilution law. So in the last class itself I have given what exactly Ostwald dilution law, but the final formula I am going to write here. The degree of dissociation of a weak electrolyte is inversely proportional to its molar concentration. Okay, so this is applicable for what? Weak electrolytes. Weak electrolytes. It means concentration, like molarity, normality we are saying now. So concentration will be what? Number of moles by volume. Number of moles are 1 and volume here. So how this is related? Concentration is inversely proportional to volume, right? So degree of dissociation will be inversely proportional to concentration, or you can replace that with 1 by V, that is nothing but Ka into V it will be. So it means what happening here, if volume of the solution increased, therefore degree of dissociation of weak electrolyte increases. So this is what Ostwald dilution principle says, that for a weak electrolyte its degree of dissociation increases. It means dissociation of that particular weak electrolyte will be more if we dilute it. So upon dilution degree of dissociation increases for weak electrolytes. This is the statement you should remember for this from this Ostwald dilution principle. Okay, right. Next. So here we have self ionization of water. So what do we mean by self ionization of water? So just take water. Water is a weak electrolyte. Okay, so it will dissociate like H plus and OH minus ion. So this is at 25 degrees Celsius I am discussing. Our discussion is at 25 degrees Celsius. So at this 25 degrees Celsius, concentration of H plus ion and concentration of OH minus ions are found to be 10 power minus 7 molar. So this is at 25 degrees Celsius. So now what you can say, now since it is a weak electrolytes I am saying, we can write its degree of dissociation constant like dissociation constant K as concentration of H plus ion multiplied with concentration of OH minus ion by concentration of water, that is pure water now. So you just write it as K double ionic product of water simply as H plus and OH minus ion. Okay, and what we know, the concentration of H plus and OH minus ions are equal, that is 10 power minus 7 into 10 power minus 7, that is 10 power minus 14, 10 power minus 14, and that is m square. Okay, that's it. This is the Kw value. Okay, so what is Kw means? Ionic product of water is how much? At 25 degrees Celsius it is 10 power minus 14. Okay, 10 power minus 14. Okay, if I discuss same story at 90 degrees Celsius, Kw will be equals to 10 power minus 12. Okay, 10 power minus 12. That means concentration of H plus and OH minus ion at 90 degrees Celsius almost equals to 10 power minus 6. How much? 10 power minus 6. This is at what temperature? 90 degrees Celsius. So from this what we can understand, the degree of dissociation, the water dissociation, ions formed from the water or the ionization of water takes place by increase in temperature. So if we increase the temperature, ionization of water is taking place. So dissociation of water is an endothermic process. What is that? Endothermic process. Endothermic process. Now there is a question like Kw of water will be increased by what? By increasing the concentration of H plus or by increasing the concentration of OH minus or by both, or the third statement is given as fourth statement by increasing the temperature. Yes, which statement is correct? Kw ionic product of water increases with increase in temperature, not by concentrations. Just by increasing temperature it will be more dissociated, therefore its formed ions will be more, therefore its product, ionic product will be more. Okay, just by increasing the temperature we can increase the ionic product of water. Okay, so this statement you should remember. Okay, let me check once. Next, here one more thing, what I told you, Kw is equals to concentration of H plus and OH minus, which is equals to 10 power minus 14 right now. So now just apply log on all the sides, like log Kw equals to log of H plus, log of OH minus and log of 10 power minus 14. Okay, and just insert negative symbol all the sides, negative, 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 minus, minus, minus. See, minus log Kw. Okay, and this one you can write minus log H plus ion plus minus log OH minus ion, which is equals to minus log of 14 means, see, simply you can write this as minus of minus plus 14, log 10 1. Okay, that's it. So now you can see this, whenever we have something like p power a, See, I have minus log of A. So you can write this as P power A. Okay. So here I have minus log of concentration of H plus ion. So it means I can write this is P power H, pH. Okay, that's it. So this becomes pH and this becomes POH. Total sum will be equals to 14, because here this you can write pKW. So pKW at 25 degrees Celsius is equals to how much? 14. At 25 degrees Celsius it is equals to 14. Okay, that's it. Okay, if it is at 90 degrees, that will be equals to 12, because pKW at 90 degrees will be 12 na. Why? Like kW at 90 degrees is 10 power minus 12, I told you. Why? The degree of dissociation is increased as temperature is increasing. Okay, that is a basic understanding, right? Next up to here it is clear, I hope, right? If I want POH for an acid or for a base, you just use this 14 minus pH, that's it. So now they simply ask what is the pH of 10 power minus 3 molar HCl. So what to do? HCl is a strong acid now. So strong acid means concentration of H plus ion, like strong electrolyte, will be H plus ion by Cl minus. So whatever the concentration of HCl is there, same concentration will be there for its H plus ion, because it is a strong electrolyte. The total H plus ion comes from this acid only. So how much it is? 10 power minus 3. If it is 10 power minus 3, pH can be written as minus log concentration of H plus. Okay, that is minus log of 10 power minus 3. That is nothing but 3. pH is how much here? 3. That's it. This will be your answer. Okay. And similarly, if I ask POH for the same solution, just 14 minus pH. That is 14 minus 3 is 11. That's it. This will be your answer for POH. Okay. And next, if I give you 10 power concentration of H plus as 2 into 10 power minus 4, what will be your pH? So you can just use, if there is concentration of H plus ion in this format, x into 10 power minus y is there, just use y minus log x. Okay, this will be the pH. Okay, because just apply log on both sides, you will get this thing only. Okay, minus log on both sides, if you apply, you will get this thing. Okay, so you can say that is 4 minus log 2, that's it. So you can write 4 minus log 2 is 0.3, so it will be 3.7. pH is how much? 3.7, that's it. Hope this is clear without having any confusions, right? Let me show you the questions that are asked on this pH based calculations. See, look at this. Based on acid base theories and pH based calculations, see what they are saying, the conjugate base of H3O plus ion. So I have told you that an acid and base pair, acid base pair are just differ by one proton right now. So now they are saying conjugate base of H3O plus. See, if this is an acid, a base should have one proton lesser than the acid. So just write one proton lesser than its acid, that is nothing but H2O. So H2O will be the conjugate base of this H3O plus ion. Right now? Right. Right. Let me choose the answer here. Yes. First option A will be your answer for the question. Next. pH of 0.01 normal lime water. See, they are saying normality. So normality, because you need to calculate pH or POH using the normalities, not by the molarities. If you do with molarities, you might ended up with wrong answer whenever the n factor is be different. Okay. So now lime water is a basic solution now. Therefore, this concentration, this 0.01 normal is mentioned now, that is a concentration of OH minus ion. So what is the concentration of OH minus ion? That is 10 power minus 2. If it is 10 power minus 2, then apply minus log on both sides. Therefore, you can get POH, that will be equals to 2. POH equals to 2. but they are not asking POH, they are asking pH. So what to do? pH will be equals to 14 minus POH. So it will be 12. So here you have option C as a 12, right? Next, look at the next question. Ammonia is a Lewis base because it is. So how ammonia will be a Lewis base? See, what is this Lewis acid base concept? See, Lewis acid base theory says electron pair donor and electron pair acceptor. So electron pair acceptor is an acid and electron pair donor is a base. Okay. So now as per the Lewis acid base theory, ammonia is what? Write the structure of ammonia. See, just NH3 with 2 electrons, like lone pair electrons right now. So these lone pair electrons can be donated. So electron pair donor is what? Electron pair donor is Lewis base. So electron pair donor, so Lewis base, option 1. That's it. How simple it is. All these questions which I am showing on the screen are from EAPCET PYQs only. See, 2022, 22, 22, all these are previous year questions only. Okay. So now once after attending the sessions, you just try to solve few more questions on your own from any of your books. I mean books related to this EAPCET, like PYQ books or your college books or anything, or you just solve the questions that I am giving you here on the screen as homework. Okay. And if you want few more questions to be practiced, you just go through the live sessions that I have made previously, like last year EAPCET also I have made. You just watch them also if you want to learn more, I mean more questions to be solved. Like PYQ sessions are also made on EAP last year. Okay. 2025 paper is solved, 24 papers are solved. You just go through those discussions also, paper discussions also, so that you will get more clarity, like what type of questions they are asking in the exam, like subject wise. Okay. Right. Look at this question. What they are saying, what is the pH of NaOH solution when 0.01 gram of it dissolved in the water and made to 100 ml of solution? Just find concentration of NaOH first. It means molarity of NaOH you find. Okay. So how much it will be? Number of moles of NaOH by volume of NaOH in liters. If it is in ml, you multiply with 1000. So given 0.04 grams of NaOH, that is 4 into 10 power minus 2 grams of NaOH. And what is the molar mass of NaOH? It is 40. Okay, multiplied with 1000 by what is the volume of this NaOH mentioned? 100. Take here 100. So this will be 2 zeros removed, and this 0 also removed, 4 also removed. So molarity is 10 power minus 2. Molarity is how much? 10 power minus 2. If molarity is 10 power minus 2, then POH will be how much? See, I am not calculating pH, I am calculating POH because it is OH minus. Okay. So minus log of concentration of OH minus. So how much it is? So simply you can take minus log 10 power minus 2. This is POH is how much now? This is 2. That's it. This will be the POH. But they are asking pH. So pH plus POH equals to 14. From this pH will be 14 minus 2, it is 12. So here option D will be as 12. That will be the perfect answer for the question. Okay, right. Let me move forward and look at this one more question mentioned here, pH of an aqueous solution of NH4Cl. This one, try this. NH4Cl means what type of compound it is? It is a salt, right? Ammonium chloride. So NH4, this NH4 forms from NH4Cl forms from NH4OH plus HCl. It's a strong acid and a weak base combination right now. So upon hydrolysis of this solution, see, aqueous solution of this salt is mentioned. So aqueous solution of this salt will contain ammonium hydroxide plus HCl. So HCl is a stronger acid now, therefore H plus ions will dominate in the solution. If H plus ions are dominating, then the solution pH will become less than 7 right now, because on pH scale we have from 0 to 14 and the midpoint here is 7, which is neutral. So if it is lower than 7 we can say acidic, and higher than 7 we are saying basic right now. So if it is close towards 0 then we can say it's strong acid, if it is towards 7 weak acid right now. So here HCl is there, which makes the solution to be acidic, therefore pH will be less than 7, pH will be less than 7. So option C is your answer for the question. Okay, right. Let me give you few more questions. Before giving the one more question, just tell me this pH of 10 power minus 5 molar NaOH. What is the pH of this solution? Tell me. Yes, anyone can answer. So what to do? I have given OH minus. So whatever the concentration mentioned, this is for concentration of OH minus right now. So find using this 10 power minus 5, find POH first. After doing that you convert it into pH. Okay, that's it. That will be your answer. Just mention me what is your answer in the chat box. Okay, so practice, try it and tell me your answer in the chat box. Now look at these. The Ka values of different acids A, B, C are mentioned like this, okay, respectively, the correct order of their acidic strength. See, simple, I am saying if HA is a weak acid, again how it will dissociate? H plus and A minus right now. So acid dissociation constant Ka is now directly proportional to concentration of H plus ion, concentration of A minus ion by HA. So if more is the ionic concentrations, more is the product concentrations, more will be the Ka value right now. So if it is a strong, like it is having more ability to dissociate, see if it is having more acidic strength, therefore equilibrium moves forward. If equilibrium moving forward, concentration of products will be more. If concentration of products is more, Ka value will be more right now. So looking at the Ka values, the one which is having greater Ka value is a stronger acid here. So more acidic strength that acid is having. So now look at this Ka value 10 power minus 4, 10 power minus 10, 10 power minus 8. So which is having greater Ka value? Acid dissociation constant of this first one is more, A is more, then after that C is more, ACB. ACB will be our answer. ACB here, option 4 will be the perfect answer based on the explanation. I hope this is clear, right? If this is clear, just click on the like button once. Yes, let's move forward. Again, look at these questions. Which of the pH of 10 power minus 8 molar HCl solution is? So how can you calculate this? See, whenever there is acidic solution is mentioned, like strong acid HCl is given, so that acidic solution pH must be less than 7. What I am saying, it should fall between below 7 to 0. So between 0 to 7 it should be there. pH of that solution, acidic solution, must be 0 to 7. Okay. So now here you can see they are saying 8 and minus 8. So ignore them. Okay. Between 8 to minus 8 to 7 to 8, that is also ignore. You can directly choose option D. But for this I will give you proper explanation how to calculate that value also. See, pH is equals to concentration minus log concentration of H plus ion. So this H plus ion should be expressed in normality. So this H plus ion, see, I am taking the solution of acid here. This is what? Acid solution in the beaker. So now what we have? One acid is there, along with that water will be there. So it means acid will provide one H plus ion as well as water will also provide H plus ion now. Yes. So now whenever the concentration of H plus ion that comes from acid is less than 10 power minus 6, then you should consider the concentration of H plus ion that is coming from water also. What is the concentration of H plus ion coming from water? 10 power minus 10. And what is the concentration of H plus ion coming from this acid? 10 power minus 8. So this will be written as 1.1 into 10 power, see what I am taking here, 0.1 into 10 power minus 7, and I can write this one right now. That is why it is becoming 1.1 into 10 power minus 7. Okay, hope this is clear what I have written over here right now. Then next, so now what happens? So pH will be, so take this value and substitute over here, minus log concentration of 1.1 into 10 power minus 7, that is it. So it will be 7 minus log 1.1. So this will be around, see log 1 is 0 but it is log 1.1. So that will be 7 minus around 0.04 something like that. So it will be 6.996 like that. So it is lesser than 6, greater than 7, that is why option D will be your perfect answer for the question. That is it. This is the simple explanation involved in this question. Next, which are the following has highest pKa value, highest pKa value. So simple, see what I told you, if the acid dissociation, see in the last question I told you that if this dissociation is more, it means if it is a more acidic, if it is more acidic, its Ka acid dissociation value will be more right now. If this Ka value is more, how it is related to pKa? I just told you that pKa, if you are writing Pa, then it is minus log Ka. Here I am writing pKa, you can write minus log of Ka. So if Ka value is more, then it is minus symbol is there now, that is why pKa will be less. For a stronger acid, Ka value will be greater, pKa value will be smaller. Okay. So based on this, you can answer me here. So which of this is highest pKa? The stronger acid will be having lower pKa. So weaker acid will be having higher pKa. So which is weaker acid here? HF. So why HF? Hydrogen and fluorine are having similar sizes, like their orbital overlapping will be very strong here. Therefore, the ability to donate H plus ion is less here. Therefore, this is weaker acid, so greater pKa. So you can opt for option B as your option. See, you just take fluorine, halogens, fluorine, chlorine, bromine, iodine. So these halogens along with the hydrogen, HF, HCl, HBr, HA. So due to the small size of these hydrogens but larger size of this halide ion, like iodide is larger now, there will be very weak bond. Bond strength will be weaker in HI case, it will easily breaks, H plus ion comes out easily, therefore HI will be having more acidic nature. So pKa will be least in HI. So if I ask for the order, so least is for C, and the next for D, and the next A, and highest is for HF, B. That is it. Hope concept is clear, complete explanation is also clear right now. Next, let us move forward. Yeah, next I will give you few questions that so that you can you answer me this? The ionic product of water, that whatever we discussed till now, concept is completed. Now I am giving you the questions also. So if you practice them, you feel confident on your preparation. So tell me the ionic product of water dash with increase in temperature. What happens? So ionic product like dissociation of water is an endothermic process. So increases, ionic product will increases with increase in temperature because it is endothermic process. So forward reaction, dissociation of ions, formation of H plus and OH minus ion will be favored by increase in temperature. Therefore, if more concentration of H plus and OH minus ion, more is the value of Kw. So increases with increase in temperature. So option B will be your answer. Okay, right. Next. Next thing, finding pH of weak acids. How can we find pH of weak acid? Till now whatever we discussed, that is for strong acids. So when it comes to weak acid, for example like acetic acid is there, so it will dissociate to form acetate ion and H plus. Okay, if I say that the concentration of this acetic acid is C and its ions will be 0 at initially, after some time they will dissociate to attain this equilibrium. Here this will be C alpha, as C minus C alpha is the degree of dissociation indicated with alpha. Therefore C minus C alpha is the amount that is consumed or converted from this acid to the respective ions. Okay, so what is the H plus ion concentration we got? That is here C into alpha. So we got H plus ion concentration as C into alpha. So now this alpha value, if we know, directly we can get H plus ion concentration, that you can substitute in this formula, minus log concentration of H plus right now. So now C means concentration of that acid into degree of dissociation, to what extent it is undergoing dissociation, because in case of strong electrolytes like HCl, like strong acids and strong bases, alpha value is almost equals to 100% dissociation, but these are weak acids now, so degree of dissociation will be lesser, either 60%, 40%, 70%, depending upon the compound to compound it varies. Okay, so now how can we find this alpha value? So just at the beginning of this session I have explained Ostwald dilution principle, where I discussed alpha is equals to root over Ka by C right now. So you just substitute this value over there, so that we will get the formula as C into root over Ka by C right now. So this you can write root over C square into C by C, we can write it like this, right? Next, so C can be cancelled, so that we will get root over Ka into C. This is the concentration of H plus ion. Okay, so now what I am asking, pH I want. So pH means you can write pH equals to minus log of H plus ion, which is nothing but, apply minus log on this side also, minus log of Ka dot C power 1 by 2. Root I can write 1 by 2. So that 1 by 2 write here 1 by 2 minus log of Ka plus minus log of C. So minus log of Ka means pKa, right? So you can get pH as pKa half into pKa minus log C. This will be the formula of pH for weak acids. Okay, so now sir, what is the use of doing all these things? See, they will simply mention what is the pH of 1 molar acetic acid is dash by given pKa equals to 4.74, like this they will mention. So what to do in that case? So pH is equals to half into pKa. How much pKa is mentioned? pKa is 4.74 minus log C. log C is how much? Concentration is 1 molar. Therefore, log C becomes log 1, 0, right? So, next 1 by 2 into 4.74, you can say pH will be equals to how much? This will be 2.37. So, 2.37 will be the pH of this particular solution, you can answer. Okay? So, I hope you got how to calculate pH of even a weak acid by looking at this formula. Okay? And next, I am giving you one question, just try to answer me. What is the pH of 0.1 molar NH4OH having pKb equals to, you can take pKb as 4.74 only here also. So, this is an like a approximate question you can consider, like a hypothetical question you can consider. So, tell me what is the pH for this particular solution. Just for making you clear with the concept, I have made this question. So, just tell me what will be the pH of this solution, pH of this particular solution in the comment box. Okay, this is the pKb value given, this is concentration given, find pH. So, identify whether it is weak acid or weak base, then try to use the formula to get the answer as above. Okay, right. Next we have to discuss a few more things. Yes, let me give you the discussion of few more things. See, look at this, we have discussed about Ka, Kb. What is this Ka, Kb again? See, for acids dissociation we are saying Ka, that if more Ka value, it means more concentration of ions, more will be the Ka value, greater is the acidic nature. So, in the exam they may ask acidic nature, acidity they may ask, or pH they may ask, or they may ask H plus ion, or simply acid strength they may ask acidity, or acid strength they may ask acid strength, or you can say K. So, all these terms are same only here, order will be same for all these terms. So, if they ask for pKa, you just take reverse of this, pKa will be reverse of this. Even they ask for pH order, you take reverse of this. So, more Ka value, lower will be the pH. For a stronger acid, Ka value will be greater, pK value will be smaller, and pH value also smaller. So, this is how you can make the orders for pH, pKa, Ka, all these things. Similarly, for Kb directly proportional to basicity is basic nature. Okay, they may say basic nature or basicity, Kb, order if they ask, you just write the stronger base, more will be the Kb. Okay, and if they say for pKb order, you take it as reverse pKb. Generally, where we will be seeing is this application will be seen in the case of alcohols as well as like phenols acidic strength, or carboxylic acid acidic strength, or amines basic strength. What they will ask is what is the order of pKb for the given amines, or what is the order of pKa for the given carboxylic acids. Let us make one question. Kb directly proportional to basic strength, basic nature, and inversely proportional to pKb, and you can say it is inversely proportional to pOH or directly proportional to pH. I mean, these are proportionality, means it is not any relation. This is to make a conclusion from the given compounds, that is it. For example, I am giving you acetic acid and chloroacetic acid and fluoroacetic acid is mentioned. These are the three compounds mentioned. They are asking Ka order. How can you give the Ka order? Which is more having more, the one which is having more Ka will be which one? Increasing order of Ka. Okay, so Ka is nothing but acidity now. More acidic, more will be the Ka value. Okay, so what to do if electron withdrawing group like fluoride, fluorine, chlorine is there, that acidic nature will be increases. So it's more electronegative, that increases the acidic nature. So this will be having greater acidic character. So C will be more, then B, and weak is A. That's it. This will be the order of Ka. If they ask for pKa, this is the order of acidic strength or Ka. If they ask for pKa, so it should be C less than B less than A. It is reverse of above. That's it. Hope whatever we discussed here are clear without any confusions. Right now? Right. So the things are clear means you just click on the like button, and in the next class we will be discussing about common ion effect and applications of common ion effect using Le-Chatelain principle, like finding the pH of buffer solutions, how this buffer solution and buffer action will be discussed, and how they act. All these things will be discussed, and once after doing that, one more important topic is there, that is what? Solubility and solubility product. Yes, if we discuss these things, then equilibrium chapter, ionic equilibrium will be completed. That's it. Okay, hope you like the session. So if you like the session, just click on the like button and do not forget to subscribe the channel. Thank you for watching. Stay connected.